Welcome to Data Science Now, a podcast by Closter with your host Fabio Vasquez. On today's episode, we'll learn how to discover valuable insights from data through data science. Follow us on social media at Closter Team. This is Data Science Now.
Welcome, everyone. I'm sorry for the delay. We had a technical issue. We're streaming with a new platform now, so hopefully everything goes well. Hopefully you're seeing my camera and hearing my audio. All right, so let's not waste any more time and get started. Just a quick reminder, we are in Data Science Now session. This is session number 6 of the season number 2. And the idea of this conversation we're going to have today is to talk about something called knowledge discovery in data science. We've been covering several different things in the past. We've been covering the business understanding section of data science, data collection, how to explore and prepare data. And now it's time to start thinking about what are the ways we have in data science to get knowledge and insight from our data. I'm going to be checking the live comments in here. So let me know if you have any questions in the process of me talking. Hopefully I can answer them correctly. Okay, so let me tell you something right now. The idea of getting knowledge, it's not something unique to data science. It's something that we do a lot in the world of science itself. But what do we do, or what do we mean when we mean knowledge? For me to explain you, I have to go back some centuries ago and talk about something that I've been talking in the past, I think in some episodes, but I think it's important to mention right now. Science was created a long time ago, but we're gonna set up the start of science in a publication by Descartes called the method, okay, or the discourse of the method. In here, he mentions that science is in the look of knowledge, not the actual truth. And this is important because this is the beginning of thinking about that science doesn't need to go and search for the actual truth of things. It's looking for acquiring and getting more knowledge. And knowledge is this thing we have when we are learning more and more about something. We're gathering information, we're creating experiments, we're doing all of these things that are in the world of science. We do that to get knowledge and information and insights about a topic. All right, so science is about getting knowledge, and data science was founded on the ideas of data mining. And I think this is a good time to start talking about a historical overview of a methodology in data science. Let me tell you something, that data science needs a methodology. We need a method to work. And we have been talking about that in the past episodes. We've been talking about the world of business understanding is part of the method, the world of data collection, the ideas of data exploration and data preparation. Those are part of a method that we're going to go into detail for each one of these parts in the whole of this season. But what is a methodology? I think that's a good question to answer. And we're going to define it as the discussion of methods. This will include the theoretical ideas and the concerns that inform the use of different methods. A method for us will be the practical steps to create or to do an investigation. So we are in the theoretical realm. We're talking about the ideas of methodology. And I mentioned this before, but data science, for most people, is not a science. But for a lot of people, including myself, I think it's useful to think about data science as a scientific field, because if that's the case, all of our products or all of the things we do have to be reproducible, followable, collaborative, creative, and we have to think about regulation. So when we start thinking about the ideas of science and the scientific method and how to apply that to data science, we come to the idea of a methodology to do data science. And that's what happened with data mining as well. So before we were talking about data science and all of this, data mining was the new kid on the block in the 90s. And in the 90s, we developed a lot of different methodologies to do data science. So, what happened back in the 90s? We were having a lot of interest from companies, the academic fields, industry, and even the governments to start thinking about how we can get information and insights from data. Why? Because in the 70s and in the 80s, we were collecting all of this information, and we realized that that was something to think about, and we should be caring about doing something with that data. So what we start doing was, okay, so we're doing something with data, but to be able to create a general method to work with data, we need a methodology for what we called back then data mining. One of the first methodologies to do data mining was called the CRISP DM. CRISP stands for Cross Industry Standard Process, and DM for data mining. So we were start thinking about the ideas of, okay, so we have data and we want to get to the insights. We want to get something out of it, but we need a process. And so in the CRISP DM, we started to talk about the business understanding part, the data understanding, data preparation, modeling, the evaluation of our models, and then the deployment, and all surrounded by the data. So this is the beginning of thinking about a methodology that help us work with data, with any type of data you have. You can argue here that data mining is old, and it's kind of true. It has more than 20 years, but a lot of the things we talk about right now in data science are just, or maybe the same or very similar to what we did in data mining. The difference maybe is that we now have more power for the computers. Now we have better methods, better algorithms, better tools and systems to work. So we are more focused right now and more into the machine learning part. But all of these things were very important as well back in the 90s. So this was 1996, where companies like SPSS and Teradata created this methodology. In the same year, a person that I admire a lot, Gregory Piatetsky, and more people created something called KDD, or knowledge discovery in databases. Now you can start thinking about the name of this session. So knowledge discovery in databases was founded in 1996, almost the same time as CRISP DM. And the idea of this KDD is a theoretical and also a methodology to discover useful information and knowledge from databases. And that's the idea of what this was. By the way, I'm going to be putting all of these images for the methodologies and also the links, so you can see more about that in the newsletter. Okay, so the KDD process was selection, pre-processing, transformation, data mining, interpretation and evaluation. And if you follow that process, you will get to knowledge. And that's the idea of KDD. Something interesting that one of the steps in KDD is data mining. So the crisp VM, what's the whole idea was to do data mining, but in KDD, we have data mining as one of the steps for getting knowledge out of information. So the idea in here is almost the same. We'll cover in some minutes the differences and similarities between these methodologies, but you can start seeing a pattern in here. And the pattern is that we all want to model, we all want to create and to obtain useful information out of data. And that's one of the ideas of data science. Remember that data science is working to solve business problems, but you need to add value. You need to create algorithms to solve problems that add value to the company. If you're not adding value with your algorithms and your studies, sadly, you're not doing what you're supposed to do. Great. So several years later, we come to the team data science process. And this is a methodology that was created by Microsoft like 4 years ago. And the idea here is that they started to think about the life cycle of data science itself. This was one of the first methodologies of actually data science, not data mining. And it's very useful because, again, it's based on KDD and is based on CrisDM. So you can, if you are already using them, it's simple to go and like transform your company to use something like team data science process. And it contains almost the same information: business understanding, data acquisition and understanding, modeling, deployment. But it adds more stuff like feature engineering, model training, model evaluation. It talks about the environment, the wrangling and cleaning of the data. It includes the idea of scoring performance and monitoring of our models. And finally, the customer acceptance step before ending the project. So again, this is another way of transforming the ways of data science into a method that we can follow to create and transform data into actual knowledge. The last one I want to talk about is called the Business Science Problem Framework. And I've talked about this before. And this was created by Matt Dancho in 2018. And again, it's based on CrisDM as well. But it is more like a business-focused methodology for data science, because the idea here is not only to get knowledge out of the data, but also to have a financial impact on your company. So one of the differences we have with this type of with the BSPF that is called is that we're not only interested in getting knowledge and information and insights, we're also interested in impacting and thinking about the financial benefits of our models to the business we're working for. So what I just did was a basic overview of the 4 most important methodologies of data science we have right now. 2 of them were created for data mining, but you will be surprised on how many companies are using right now CrisDM or KDD to do data science. So we're gonna put them in the same plane. They're all gonna be methodologies to do data science. So that's the first part. This is the overview of what we're doing to get insights from our data. I've been basing these sessions for the season 2 in a methodology that I have been developing in the past years. And the methodology I've been developing, it's a combination and is trying to get the best out of these four that I just mentioned, and including the ideas of software engineering and data operations. I'm going to be publishing that very, very soon. And the idea is to have a whole view or understanding on the data science process and how can we get value out of data. The methodology I am proposing goes from data to value, and I think all of them do the same. But I'm trying to include more things about the development of the algorithms, the continuous integration, continuous deployment, how to validate and version data code and models and stuff like that. So that is the basic idea of the set of these methodologies. And now it's important to think about what are the comparison between them. And this is important because when you're trying to do data science for a company, you need to decide which methodology you're going to be following. And this is not something that is just trivial. You really think you have to think about this, because when you're starting to do data science, you want to go and you want to think about what are the advantages or disadvantages I have if I use ChrisDM or KDD or the team data science process or the BSPF, and what should I be choosing for my own company. So let me just tell you very fast some of the advantages of the ChrisDM methodologies. First, is widely used by a lot of different companies all around the globe. It has a high level of maturity and documentation. You have a lot of great examples and use cases, and is focused on the business understanding and getting the context of the problems. So those are the advantages of the ChrisDM. What are some of the disadvantages of the ChrisDM? Is stuck in data mining. And what does that mean? That, okay, yeah, we have been using almost the same topics and terms for data science and for data mining, but data science needs more agility. You need to be able to iterate more over things. You just to start thinking about more in detail about feature engineering, data exploration, and modeling and deployment of the models. You need also more information about the versioning of all of these things are not included in ChrisDM. So you don't have that for ChrisDM. So first, again, it's stuck on data mining. Second, it doesn't contain any method for agility. It doesn't contain any method for software engineering. So it won't tell you anything about creating good quality code. And you are missing some interaction levels between the steps. Now let me go to KDD. Advantages. Again, is mature, is widely used when you have relational databases. If you have relational databases or something like that, it's widely used because KDD was created to work with databases with like MySQL or SQL Server or Teradata, stuff like that. So if you have that type of data, the process of KDD works for you very well. And is focused on the knowledge and on getting knowledge and understanding through data mining and machine learning. Some of the problems with KDD, I think it has all of the problems that ChrisDM have. It's not that widely used, so you won't find that many documentation or use cases for it, and you have a low reaction to change. So if you're working in a highly change, like in a highly agile company, or you need to be able to adapt a lot to changes from clients, KDD is not the best way for you. I have a question here from Mario, and he says, should we keep using ChrisDM to develop data science projects? I just use it in my master thesis, but I felt that it was not updated. So, Mario, we can use ChrisDM, but I think we have better alternatives right now. I think the team data science process or the or the business science problem framework are better suited for doing data science right now. I think that a lot of the things are almost the same, but if you go into detail to the team data science process of the way the business science problem framework works for solving a data science problem, you'll see that it has much more things and much more explanations on the actual process for data science. So let me go now and talk about the advantages for the team data science process. First, again, it is being spread a lot into a lot of different businesses and companies. So we can say that it's widely used, is extremely well documented, and I think that's a very important step. I think for from all of these methodologies, the best one for documentation is a team data science process. You have a lot of documents and processes to follow the process step by step of the data science cycle. So you have a lot of different things like documents for data sources, the data quality, the modeling process, the hypothesis, the customer complaints. You have all of these documents created for you to like start documenting all of the process of data science, and I think that's very useful. One of the things that can be useful is that it's integrated in Azure ML. So if you're working with Azure right now, it's a great place to start using the team data science process. And also, it integrates a lot of different profiles in the process of data science. And I think that's quite interesting as well. Okay, some of the problems with the team data science process, you don't have that much examples of or use cases, so you don't have like reports of companies using it yet. I think we'll see that sooner than later, but not happening right now. It may be confusing for some organizations that are not well uh, prepared in the world of data literacy, or they don't have a data culture in their company. So you will need to have a better understanding of data science to be able to apply the team data science process. I mean, if you're working right now with something like KDD or something like ChrisDM, going into the team data science process is not that hard. And for some aspects, it will force you to use Microsoft platforms. So I don't like that much because, I mean, if we're working with like other platforms, you will need sometimes to use Azure to use some of the things that they created. So that's not the best. By the way, for the people asking, this is being recorded, and all of our sessions are on YouTube right now. You can find this on YouTube and on Spotify as a podcast. So you have to search for Closter on YouTube, and you will be able to see all of the past sessions. Okay, finally, the advantages of the business science problem framework. I think one of the advantages we have for this is that it's 100% focused on business applications. And most of data science processes and projects are for working in business. So if you're working in business, I think it's a great place to start. It's easy to adapt and to use because it's like highly based on ChrisDM. So if you're using ChrisDM, it's super simple to move to the BSPF. It has some examples on how to use it, and it has a financial approach that makes easy to measure the ROE and also the KPIs. I think one of the best things of the BSPF is that it contains a lot of great information about KPIs, how to measure things in a business and stuff like that that are missing from the other methodologies. Some problems with the BSPF, it's not widely used. I don't think a lot of companies are using it right now, so you don't have that idea on use cases or documentation for that. It is, again, highly focused right now on business. So if you're not working in a business scenario or you're doing design for something different, this won't work for you. So I think those are the biggest problems. So for the one I am creating right now, it is highly based on the BSPF, but it will include agility. It will include concepts of data operations and software engineering. It will be able to generalize to not only a business case but any type of business case. And I'm trying to get the best out of the methodologies we have right now. So hopefully for the newsletter, I'm going to be putting some of the information of the methodology I am creating. But that's going to be a different article that I'm going to be publishing later this year. Great. So we have discussed the ways, like the historical overview of the methods to do data science. And again, if you want to know more about like what's data science and stuff like that, I have covered that in the past episodes. Uh, right now, we're talking about this because I have already covered business understanding. I have already covered data collection. I have already covered the ideas of data exploration and preparation. And you need all of this before start thinking about getting insights out of your data. Like modeling and getting knowledge depends on you understanding the context of the problem, depends on you understanding the KPIs of the business, depends on you to explore and collect the data and all of these things. So now what I want to talk about is the process of actually getting knowledge out of data. So if you follow these methods, you will encounter maybe some insight out of your information. But what is the idea behind all of this? The idea behind all of this is the concept of a model. A model is an abstraction of reality. We have the real world, and because it's super complicated to understand, we will be assuming some things. We will be like trying to find a boundary where we can work. And inside of that boundary, with the limitations we have and the assumptions we have, we're going to be modeling that. Okay, so the first part of modeling is to create that boundary, to set up the limitations you have, to write down your assumptions, and then you can start thinking about modeling. So modeling is a process of getting information out of nature by assuming some things and by abstracting the real world. And in that process of abstracting the real world and all of that, we have to come up with a mathematical model for a process. All right. So modeling is applying mathematics to a process in nature to be able to understand it better. And that's what we do all the time in machine learning. So machine learning is one of the ways we have to create models. What type of models we have in machine learning? The models that will allow us to predict the future from past data. Okay, not all of the models are the same, but the models we use in data science and in machine learning are aimed to predict something using past information. Okay, so machine learning is one of the processes we have for that, and it is the process of finding the best parameters for those math functions that we developed to explain a process. I'm going to be covering this into more detail when we go and talk about machine learning and modeling, but I want you to understand that to be able to get insights and knowledge out of your data, you need to go through the steps of modeling. You need to go through the steps of all of this. Something important here as well. Sometimes you don't need a machine learning model to get insights from your data, because in the part of data exploration and in the part of data preparation, you will be getting information, statistical information out of your data, the graphs, the metrics, the means, and all of those things are information out of this. But to get knowledge out of your data, you need to go to the modeling process, and the modeling process will include all of the things that are being super used right now, like machine learning and deep learning, neural networks, and TensorFlow, and all in Python and R, and all of these great tools. We use these tools to get the knowledge out of our information. But just a quick reminder, this is following a method. This is following a process. The process that we call a methodology for data science. We have different ways of doing it. You need to decide which one is the best for you and your company. When you follow that process, then you will go and be able to start thinking about finding good sources of information, finding knowledge, finding useful insights out of your information and data. So that is it for today's session. I just wanted to cover the basic ideas of the methods in data science, and the methodologies, and the historical overview, and the ideas of modeling before going into actual modeling and machine learning. In the next session, I'm going to be going into detail about modeling and the math behind machine learning and machine learning itself. But you really need to think and understand that all of this depends on you doing all of the steps before that. If you don't do the steps before that, it's going to be impossible that you find all of the information here. Right. So thank you very much for being here. Thank you for your time. And hopefully this was useful for you. I want to thank my whole team, Gabriel, Eileen, Hazel. And so thank you for that. And we have reached the maximum time here. So hopefully we don't have the errors for the next session. And see you soon. Bye-bye.